Morning. So in the last class we discussed about the jet transform, the definition of jet transform, okay, and the types of jet transform, two-sided jet transform, that is bilateral jet transform, and unilateral jet transform, ROC, region of convergence. So what is meant by ROC? The range of values of z for which the equation sigma n equal to minus infinity infinity x of n into z power minus n should approach the finite value, right? That is called region of convergence. Okay, and some problems related to jet transforms. Okay, so we are continue doing the problems, right? So problem 6 is find the jet transform and sketch ROC for the discrete time sequence x of n equal to 0.6 whole power n into u of n plus 0.4 whole power n into u of n, right? Right. So x of z is this is let it be considered as term A and this is term B. Okay. So x of z equals sigma n minus infinity infinity x of n into z power minus n. Here x of n is 0.6 whole power n into u of n plus 0.4 whole power n into u of n whole into z power minus n. So here it is given as u of n. So here the limits are from 0 to infinity. From 0 to infinity only u of n value is 1, right? So it is from 0 to infinity 0.6 whole power n into 1 into z power minus n plus integral n sigma n equal 0 to infinity 0.4 whole power n into 1 into z power minus n, right? So it is equal to 0.6 into z power minus 1 whole power n plus 0.4 into z power minus 1 whole power n. This is term A and this is term B, right? Okay, so x of z is 1 by 1 minus alpha, that is 1 by 1 minus 0.6 into z power minus 1 plus 1 by again 1 minus alpha. So 1 by 1 minus 0.4 into z power minus 1. Okay. Wow. Okay. So it is it is term A and term B. Okay. So then it is 1 by 1 minus 0.6 into z power minus 1 plus 1 by 1 minus 0.4 into z power minus 1. Here mod 0.6 into z power minus 1 is less than 1. This is ROC. And here also 0.4 into z power minus 1 is less than 1. Okay. So this is z minus 0.6, that is z by z minus 0.6 plus z by z minus 0.4 with mod z is greater than 0.6 and mod z is greater than 0.4. This is the ROC. By taking LCM for this one, so it will become z into 2z minus 1 by z minus 0.6 into z minus 0.4. Okay. So for this one, we have to draw the ROC. So for first one, z mod z is greater than 0.6. So this is 0.6. It is beyond 0.6. Z equal 0.6 after here. So this is unity circle and this is 0.6. And beyond 0.6, we have the ROC. Similarly, beyond 0.4, we have the ROC. Right? That is about that problem. Then next problem is find the jet transform of the sequence. First bit is x of n equal to e power minus a n t into u of n. Here a is real, and x of n equal to e power minus a n t into u of n. Here a is imaginary. Okay. So x of z equal jet transform of x of n is equal to sigma n equal minus infinity infinity x of n into z power minus n. But it is so a is real. This is u of n. So it will become n equal 0 to infinity e power minus a n t into 1 into z power minus n. Or we can write this as e power minus a t into z power minus 1 whole power n. That is in the form of alpha power n. So it is equal 1 by 1 minus alpha. That is here alpha is e power minus a t into z power minus 1. And mod e power minus a t into z power minus 1 must be less than 1. So it is z by z minus e power minus at into z power minus 1 is less than e power minus 8. So that is the first bit. And second bit is x of n equal to e power minus a n t into u of n. Here a is imaginary. So solution is equal to e power minus 8 into z power minus 1 is less than 1. That is equation number 1. If a is imaginary, then e power minus 80 will become 1. So equation number 1 will become z power minus 1 must be less than 1 or mod z is greater than 1. So it is x of z equal to z by z minus e power minus 80 into this is the solution, and mod z is greater than 1. Here both z transforms are same, but ROCs are different. Here z is greater than 1. So here ROC will be beyond unity circle, right? Beyond the unity circle. So then next problem is find the z transform for the signal x of n equal to sin n omega t into u of n. So z transform of x of n equal sigma n equal minus infinity to infinity um, x of n into z power minus n. Okay, z power minus n. Okay, next we'll do this problem. Find the z transform for the signal x of n equal to sin n omega t into u of n. Right? So sigma n equal to minus infinity infinity sin n omega t into u of n into z power minus n. So here also u of n is given. That's why limits are changing from 0 to infinity. So sigma n equal to 0 to infinity sin n omega t into 1 into z power minus 1, right? So sin n omega t into z power minus n. As we already know that formula for sin theta is e power j theta minus e power minus j theta by 2j, right? Okay. So then x of z will become sigma n equal to 0 to infinity e power j omega tn minus e power minus j omega tn by 2j into z power minus n. Okay. Multiply this 1 by 2j, extract the 1 by 2j outside the sigma. So 1 by 2j into sigma n equal to 0 to infinity e power nj into omega t into z power minus 1 whole power n minus sigma n equal to 0 to infinity e power minus j omega tn into z power minus 1 whole power n, right? Okay, so it is equal to 1 by 2j into z by z minus e power j n omega t minus z by z minus e power minus j n omega t. By taking LCM, it will become z square minus z into e power j n omega t minus z square plus z into e power minus j n omega t by z square minus z into e power n omega t plus e power minus j n omega t plus 1, right? Or we can write this as z into e power j n omega t minus e power minus j n omega t by 2j by z square minus 2j into e power j omega t plus e power minus j omega t by 2 plus 1. Since e power j omega t plus e power minus j omega t by 2 is nothing but cos omega t. So it is equal to z into sin omega t by z square minus 2z cos omega t plus 1. So this is the z transform for the function x of n is equal to sin omega t into u of n. Similarly, for cos omega t also, cos n omega t into u of n will become x of z equal to z square minus z into cos omega t by z square minus 2z into cos omega t plus 1. Okay. And next problem is find the z transform for the signal x of n equal to 2 power n into u of n plus 3 power n into u of minus n minus 1, right? So we can write this as x of z equal sigma n equal 0 to infinity 2 power n into z power minus n plus sigma n equal minus infinity to minus 1 3 power n into z power minus n, right? So by simply substituting by doing this, so we'll get the x of z values are z by z minus 2 plus 3 by 3 minus z minus 1, right? So here z is greater than 2, z is less than 2. So by taking LCM, so it will become Term B will become P minus 3 plus Z by P minus Z or Z by P minus Z, or we can write this as minus Z by Z minus 3. Here ROC Z is less than 3. So finally X of Z is Z by Z minus 2 minus Z by Z minus 3. Here ROC is in between 2 and 3. Okay. So here if Z is greater than 2, this is the ROC. If Z is less than 3, this is the ROC. And if Z is in between 2 and 3, this is the ROC. 2 and 3, this is the ROC. Okay. So this is the Z transform for this problem. And next one is find the Z transform and sketch ROC for the sequence x of n equal to delta of n. Okay. X of n equal delta of n. So as we already know that delta of n exists at n equal to 0 only. Otherwise, remaining places its value is 0. At n equal to 0 only, it will exist. Okay, so sigma n equal minus infinity into delta n into z power minus n, but it exists only at n equal to 0. So delta n value is 1. For n equal to 0, it is 0. For n is not equal to 0, so x of z will become n at 0. It is 1 into z power minus n. N value is 0, so z power 0 is 1. So x of z is also 1. ROC is entire z plane. So ROC is entire z plane. Next problem is find the z transform and sketch ROC for the discrete time sequence x of n is equal to b power mod n, b power mod n. Okay, so the transform of x of n is equal to sigma n equal minus infinity to infinity x of n into z power minus n. So here x of n is p power mod n given into z power minus n. So mod n in the sense plus or minus n. So it is b power n into u of n plus b power minus n into u of minus n minus 1 into z power minus n, right? Okay, so it will become sigma n equal to minus infinity infinity b power n into u of n into z power minus n plus and here it will be divided like this p of n into u of n plus b of minus n into u of minus n minus 1 into z power minus n, or it is b of n into u of n into z power minus n plus sigma n equal to minus infinity to infinity b power minus n into u of minus n minus 1 into z power minus n, right? So it is u of n, that's why it is here the limits are from 0 to infinity. B of n into 1 into z power minus n and sigma n equal minus infinity to minus n. B of minus n into z power minus n. Here u of minus n minus 1 value is 1 from minus infinity to minus 1. Okay. Then it will become sigma n equal 0 to infinity b z power minus 1 whole power n plus sigma n equal minus infinity to minus 1 b power minus 1 into z power minus 1 whole power n. So if we take term a, that is 1 by 1 minus b power b into z power minus 1 or 1 by b by z or z minus b, z by z minus b, and z is greater than b. This is ROC. And for term b, sigma n equal minus infinity to minus 1 b power minus 1 into z power minus 1 whole power n, let p equal to n minus n or n is minus p, right? Okay, so it will become p equal 1 to infinity b into z whole power p. So here we are adding and subtracting 1 for this one. So 1 plus sigma p equal to 1 to infinity b into z whole power p minus 1. Okay. Okay, so it will become p equal to 0 to infinity bz power p minus 1. Now it is 1 by 1 minus bz minus 1. Okay, so by taking LCM, it will become bz by 1 minus bz. Here ROC is bz is less than 1 or z is less than 1 by b. Okay, so this is totally h of x, x of z is z by z minus b plus bz by 1 minus bz. And here ROC is in between b and 1 by b. Suppose b is 2, then it will become 2 to 0.5. Okay, it is in between 0.5 to 2. Okay, so this is the ROC is like this. Then coming to the properties of Z transforms. Properties of Z transforms. like Laplace transform properties. Here also we have the properties and all are same. All are common properties. For Laplace transform, Fourier transform, and jet transform, all properties are common. Okay, but formula will differ. Okay, first property is linearity property. Here it is defined as if the jet transform of x of n is x of z and jet transform of y of n is y of z. Here ROC is R1 and ROC is R2. Then the transform of A into x of n plus B into y of n will become A into x of z plus B into y of z. Here ROC contains R1 intersection with R2. Here ROC contains R1 intersection with R2. Okay, this is linearity property. Then coming to the time shifting property, like Laplace transform time shifting property. Here also we have the time shifting property, that is z transform of x of n is equal to x of z. Here ROC is R1. Then z transform of x of n minus n naught will become z power minus n naught into x of z. Okay. So the transform of x of n minus n naught is equal to sigma n equal to 0 to infinity x of n minus n naught into z power minus n. Okay. So if n is 0, then this is here n equal to n naught. N is n naught plus 1. Here n is n naught plus 2, right? N equal to n naught. Then it is x of 0 into z power minus n naught plus x of 1 into n naught plus 1. So it is 1. So 1 into z power minus of n naught plus 1 plus x of 2 into z power minus of n naught plus 2 and so on. So taking z power n naught as common. So this is x of 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2 plus so on. So this will become z power minus n naught into x of z. Okay. So that is the Laplace z transform of x of n minus n naught will become z power minus n naught into x of z. Then frequency shifting property. Okay, if the z transform of x of n is x of z, here ROC is R1, and then the transform of e power j omega naught n into x of n is nothing but x of e j omega naught into z. Here ROC is R1. So by substituting e power j omega naught is z naught, so it will become z naught power n into x of n. The transform z naught power n into x of n will become x of z by z naught. Okay. X of z by z naught. So z naught power n into x of n equal to sigma n equal to 0 to infinity z naught power n into x of n into z power minus n. So sigma n equal to 0 to infinity x of n into z power minus n by z naught power minus n. Okay. So it is x of z by z naught. So here ROC is z naught into R1. Next, time reversal property. If z transform of x of n is x of z, then z transform of x of minus n is x of 1 by z. So here ROC is R1, here ROC is 1 by R1. Next, convolution property. Convolution in time domain will become multiplication in frequency domain. So the transform of x of n is x of z, that is ROC is R1, and the transform of y of n equal y of z. Here also ROC is R2. Then x of n convoluted with y of n will become x of z into y of z. Here ROC is R1 intersection with R2. So that is the convolution property. Then differentiation in Z domain. Differentiation in Z domain is the Z transform of x of n is x of z, that is ROC to R1. Then Z transform of n into x of n will become minus z into d by dz of x of z. Here ROC is R1. So x of z is sigma n equal 0 to infinity x of n into z power minus n. Now differentiating both sides with respect to z, we get d by dz of x of z is equal to 1 by dz into sigma n equal 0 to infinity x of n into dz power minus n. Then d by dz of x of z is equal to sigma n equal 0 to infinity x of n into d by dz of z power minus n into z power minus n minus 1. Okay. So it will become n into x of n into z power minus n minus 1. So minus z by dz of dxz equal to sigma n equal 0 to infinity n into x of n into z power minus n. Now final value theorem and initial value theorem. Okay. So what is the final value theorem? So it is defined as if x of n is causal and x of n equal to 0 for n is less than 0. This is the condition for causality. Okay. X of n is causal. X of n is causal. Then x of n equal to 0 for n is less than 0. Then x of 0 is equal to limit n tends to infinity x of n is equal to limit z tends to 1 z minus 1 into x of z. Okay. So we have z transform of x of n plus 1 is equal to z transform of x of z minus x of 0. That is equation number 1. So z transform of x of n is x of z is sigma n equal to 0 to infinity x of n into z power minus n. Okay. So by subtracting equation number 2 from equation number 1, so 1 minus 2 it is equal to the transform of x of n plus 1 minus x of n plus 1 minus x of n. So it is equal to x of n plus 1 minus x of n is equal to z transform of x of z minus z transform of x of 0 minus x of z. Okay. So this is sigma n equal to 0 to infinity x of n plus 1 minus x of n into z power minus n is equal to z minus 1 into x of z minus z into x of 0. Okay. So taking limit z equal to 1 on both sides. So limit z tends to 1, sigma n equal to 0 to infinity x of n plus 1 minus x of n into 1 by z power n is equal to limit z tends to 1 z minus 1 into x of z minus z into x of 0, right? So sigma n equal to 0 to infinity x of n plus 1 minus x of n is equal to limit z tends to 1 z minus 1 into x of z minus x of 0. Okay. So limit z tends to 1 z minus 1 into x of z is equal to x of 0 plus sigma n equal to 0 to infinity x of n plus 1 minus x of n. So this is x of 0 plus limit m tends to infinity sigma n tends to 0 to m x of n plus 1 minus x of n. So limit z tends to 1 z of z minus 1 and x of z is equal to limit m tends to infinity x of n plus 1. If m tends to infinity and m plus 1 tends to infinity, then RHS is equal to limit m plus 1 tends to infinity x of m plus 1, or limit n tends to infinity, this is x of m plus 1 equal to n, right? So therefore x of infinity is equal to limit n tends to 0 x of n, that is limit z tends to 1 z minus 1 into x of n. That is the final value theorem. And coming to the scaling in z domain, if z transform of x of n is x of z, then a power n into x of n, the transform of a power n into x of n is x of z by a. Okay, so where a is any real or complex quantity. So x of z equals sigma n equals 0 to infinity x of n into z power minus n is equal to sigma n equals 0 to infinity a power n into x of n into z power minus n, so that it will become x of n into a power minus 1 into z whole power minus n. So it is nothing but x of a power minus 1 into z, or it is z by a, x of z by a. And coming to the initial value theorem, x of n is larger than x of 0 equal to limit n tends to 0 x of n, or if it is equal to limit z tends to infinity x of z. Okay, so x of z equals sigma n equal to 0 to infinity x of n into z power minus n. So by expanding this, x of 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2 and so on. Taking limits on both sides for z tends to infinity, we get z tends to infinity x of z is equal to limit z tends to infinity x of 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2, which is equal to x of 0. Taking limits on both sides z tends to infinity, we get limit z tends to infinity x of z is equal to limit z tends to infinity x of 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2 and so on, which is equal to x of 0, right? So limit z tends to infinity x of 0 plus x of 1 into 1 by infinity z tends to infinity, so 1 by infinity plus x of 2 into 1 by infinity and so on. So limit z tends to infinity x of 0 plus all are zeros. So limit z tends to infinity x of 0, that is x of 0. That is the final value theorem, initial value theorem. Okay. So these are all the properties of our. Okay. In the next class, we'll discuss about these problems. Okay. With this, I am concluding today's class. Thank you.